Amazing. Hello, guys. Hope you guys are all well and having a lovely week. Tonight, Middlesex University Product Design Engineering, and Design Engineering are excited to host the 18th talk in the annual guest lecture series. So this series runs weekly on Thursday evenings, bringing together a vibrant mix of speakers from across the full spectrum of design and engineering. We have a mix of leading practitioners, we have opinion leaders, radical thinkers, and emerging talents to inspire and support your professional development. Tonight, we're really excited to host Dr. Peter Holmes, presently a designer in residence at Middlesex University. Who is Peter? I'm sure Dr. Peter will tell you more about himself in the coming moments as well, but a short summary for those who might have missed the circulated details from earlier today. So Peter was an engineer by profession. He undertook a 5-year apprenticeship in engineering in the 1950s. He then went on to work as a design development engineer for VTOL engines at Rolls-Royce. Thereafter, Peter did a BSc Science honorary degree and then went to work in Canada as a Pacific oil and gas geophysicist. In the late 60s, Peter was the chief development engineer on helicopter development and testing for Servotec, and thereafter an applications engineer at AE Electronics Limited as well. In 1970, Peter joined Enfield College of Technology, or Middlesex Polytechnic thereafter as well, as a lecturer. And he also did his PhD jointly with Middlesex Polytechnic and Cambridge University. A little interesting fact there, Peter was the first PhD graduate of the university as well. In the 1980s, Peter founded and ran a publishing company, Glentop Publishers Ltd. And then in the 1990s, he founded and ran the software company, ABCo Design Ltd, alongside being a part-time lecturer at Middlesex. From 2012 until present, Peter's been a designer in residence at Middlesex University. He worked on the EMAP project as a consultant for instrument reconstruction and the coordinator of the ancient brass team. Whilst Peter completed his PhD in ancient musical instruments in the 1970s, from the 70s onwards, he's continued researching, making, and blowing ever since. As usual, guys, feel free to gather your thoughts, your questions, your comments in the chat throughout the talk. We're going to have some Q&A at the end as well. And there's an option to go live and interact with Peter after the main talks. And over to Peter Holmes with a talk titled Design from the Bronze Age to the Digital Age and Back Again.
Hello, good evening. You've got, hopefully you can see a picture of a strange contraption in front of you. That was the first engine I worked on, first aircraft I worked on at Rolls-Royce. I was very lucky in hindsight at Rolls-Royce. I joined in 1956 as an apprentice. I didn't realise at the time that was the very first year that there were free apprenticeships. If I'd have joined a year before, I would have had to pay for an apprenticeship and I would never have become an apprentice. I did a year's training there where we learnt to work on all the different machines. And I have to say that the machine shop would have been quite at home to a Victorian machinist. The machine shop hadn't changed that much since the 19th century. They were all the standard old machines that we had to work on. I'd ended 3 years in the company going through all the different, I'm sorry about that, that's our front door going, that's the problems of Zoom. I forgot what I was saying now. I did my 3 years going through all the different branches of the company, and then finally I got to work in my final year on vertical takeoff and landing. It was very new in those days, and there weren't any aircraft taking off vertically and landing horizontally. And this thing you can see here, the Flying Bedstead, was the first of them. It used two engines, two Rolls-Royce Neen engines. And you have to realize you're talking about only around 10, 15 years since the jet engine first flew. So these were not that unlike the engines that Whittle put on his first test bed. I didn't work on that very long because they'd done all the testing. What the testing they were doing at that time was on these puffer jets you can see on the right and the left, and there's some in the front and behind, where they were trying to work out the stability of the aircraft. This was very early on in vertical takeoff. The next stage, and this is where I started working, was on the RB108. This was a very small engine. It was 2,200 pounds thrust. I don't know what that is in modern money, but it was about a ton of thrust, and it was designed to work on vertical takeoff. My job was looking at the oil system on this. This had a total loss oil system. There was no recirculation of the oil. The oil simply went through and got burnt at the end. And this was a special engine designed for vertical takeoff. And I have to say, this was our main tool we had on design. And I spent much of our time in technical college learning how to work one of these, a slide rule or a guessing stick. And all the calculations on all these aircraft you'll see were all done on this device. And it was capable of enormous accuracy, but you had to know how to use it. And some people are absolute whizzes on these. I never was. I got by. But as you can see, there are lots of different scales, and the center of the device slides in and out, and then the cursor moves over so that you can read off the top and bottom. You can do logarithms on it. You can do log, sine, cos, tan, all those sorts of things, exponentials, very, very elaborate sort of devices. And all these early aircraft were designed on these things. There was no digital computing then, and within Rolls-Royce at the time, there wasn't a single digital computer. This was the aircraft that I worked on mainly. It was called the short SC-1. SC stood for strange contraption. It had 4 engines pointing downwards and 1 engine pointing to the rear. Our job, my job principally, was getting it up to running for 50 hours without failure. It was considered if we could get this to run, this was experimental. If we could get it to run for 50 hours without failure, we'd succeeded. This is the actual cross-section of the aircraft. And you can see in the middle, there are 4 engines pointing down, 1 engine pointing rearwards. Taking off horizontally needs much less power than taking off vertically, because the lifts are providing the wings, the wings are providing the lift, and but it just needs a long runway to do it. And you can see here on the wings there are the puffer jets, and you can see the front puffer jet and the sun mounted at the back here. So this was experimental. Nobody at this time had taken an aircraft off vertically and landed it horizontally. And people were still saying it can't be done. And I can remember the afternoon that we did it. And it was a very exciting afternoon. We got radio contact with the aircraft, and it did it over the North Sea, where if it didn't work, it splashed down into the sea. And I have to say that life in aircraft was very different in those days. In the time I worked on vertical takeoff in Rolls-Royce for 2 years, in that time we lost 3 pilots, and life was very different. We didn't have all the simulation to test an aircraft before it took off. The pilot sat it at the end of the runway, crossed the fingers, wound up the engines, and whooshed down the runway and hoped for the best. Okay, all the calculations were done, and every effort was made to stop anything going wrong. But accidents did happen, and it was a relatively dangerous period in aircraft design. Worked also on this one. This was the French Balzac 5. This had 8 vertical engines and 1 horizontal. There you've got a picture of it. You can see 8 engines in the middle. One of the problems in doing a transition from vertical to horizontal flight is that as you move forward horizontally, you can't get the air into the vertical engines, so you lose lift. Unless you can get enough lift from the wings before you lose that lift, you can't do the transition. And that's what the whole game was about. The engines rocked over about 7 degrees, and that was the maximum that you could actually handle on this. So there were very experimental days, and a lot of it was seat of pants. You can see here at the front, you've got puffer jets, at the back, you've got puffers, on the wings, you've got puffers. This was another VJ101C. This was the German aircraft. And while I was working on these, they lost 2 of these. And they lost 1 pilot in one of those crashes. This had the next generation engine, the RB145, which had a gearbox and was twisted round from horizontal to vertical. Now you see this today on modern VTOL things, twisting engines on the wing. This worked really quite well, but the money ran out and the German government didn't support it, and the thing died. At the time, these engines were pure jets, so all the air went through the jet engine. There were not big fan engines, so the lift to weight ratio, the thrust to weight ratio of these engines was not high, and it was not high enough, so the engines were really pushing it. The one that worked was the Harrier, and this used a different technique altogether. It was built by Bristol and not Rolls-Royce, but the technology was using the same idea. This is the F-35, one variant of the F-35, which has the lift engine and uses exactly the same idea. So this is built really basically on the short SC-1 from 1962 or thereabouts. This is the basic principle of one of the versions of the F-35, just the same sort of thing. Now then, just to jar you all, before I started my apprenticeship, I played the trumpet. I was always interested in the history of the trumpet. And in the first year of my apprenticeship, I started making them. I got to the end of the first year in the apprenticeship, and all apprentices suffer with a rather deadly disease, in that you think you can make anything. You know, you think you're gods, you can do anything. So I started cutting bits off my trumpet and sticking bits on and playing around with it at the end of the first year, much to the disgust of anybody else playing in the same band as me, because I had bits hanging off it. But nevertheless, when I was in teaching and I wanted to do a PhD, I tried to do one in engineering. Because I was teaching engineering, but I found it very difficult for reasons I won't go into. But I was told, if you want to do a PhD, do it in something you're interested in. And what I was interested in was instruments. So I was very fortunate. I was watching television one lunchtime, and a guy came on television talking about some instruments this museum had just bought. And he was professor of archaeology at Cambridge University. And I rang him up that afternoon, and I said, oh, we seem to share a research. He was only a professor of archaeology at Cambridge, and he was fantastic. He said, yeah, come along. And I went along and we set up the PhD, and I did the PhD. I was very lucky to meet John Coles, who was a phenomenal archaeologist and he started off the whole idea of experimental archaeology. If we want to understand what this guy is doing on the left with some kind of trumpety thing, a tuba, the Romans called it a tuba, then why not make one and just blow it and see what it can play? That doesn't tell you what they play, but it tells you what they could have played. And if you've been in the workshop in the last few years, you will have heard Spike and me making noises on instruments like these. And that's what we've been doing. To some extent, it's trying to find out what these instruments would have sounded like. But just recently, we've been doing a lot of work which has exposed a lot of ideas which have not been around before. And we're beginning to understand that the level of knowledge about these instruments is far greater than was previously understood. We don't always have instruments. We don't have many instruments, in fact. if we look at the Roman and the native European period, the Iron Age in Northern Europe, we have hardly any instruments at all. This is a copy of an instrument that was found in 1688 in the River Witham. And fortunately, the guy, the rich toff whose land it was on, commissioned this drawing. And so I had a look at this drawing and decided I would like to try and make an instrument from it. Now, fortunately, this drawing had a scale at the bottom here. So the first thing I did was to have a look at the scale and to try and say to myself, well, how good is the scale? And in fact, the scale was extraordinarily good. It was very precise. So I followed from that, saying that it would be worth my while making an instrument from that. So one of the problems in music archaeology is much of the time we don't have instruments. We have a lot of iconography, and iconography has always gone through a lot of heads. It's gone through the head of the person commissioning it. They commission it for a reason. It's gone through the head of the artist who is doing it, and they're doing it for a reason. They're doing it from their knowledge. And so there are always these problems with iconography, knowing how good the iconography is. I then got involved, and the university got involved with the European Music Archaeology project. This was a project between 7 countries in Europe and involved the making of over 300 instruments. And we made our fair share at Middlesex. And we did some quite sterling work, I think, at Middlesex. Those were the countries involved. One of the instruments I took on was to make some of these. This is Tutankhamun's silver trumpet. This is among the A list of instruments we have. It's about 1350 BCE. This silver one was found right next to the tomb in which Tutankhamun was lying. Another one, a copper one, was found lying with some military things. So it looks very much like that. Well, they were very different instruments for different reasons. This is the bell of the silver one. And if you can see at the bottom of the bell, you can see that the decoration has been pressed through. Now, these are made out of very, very thin material. It's about 0.3 millimeters thick. And it's actually quite difficult material to work with. It's silver. We don't have an exact composition of it, so it could be electrum, which is an alloy of silver and gold. But the roundy edge is certainly gold, and we can tell that from looking at it. So these are the ones I made, and when I came to make them, I decided I was going to make them in the original material. So the one on the left is silver and gold. So the mouth pipe here, the long bit, is silver, and this bit is silver. I had to make this and join it 0.3 millimeters thick, which was really very tricky. And at some stage, I actually cracked the material. So I decided I would repair this, which was a very tricky thing to do. And in fact, it was far trickier than I could do. I put the torch on it and the torch went straight through it. The torch just laughed at it and went whoosh through. So I had a hole in it. So I'm afraid this one is a cheaty bell. It's actually a copper bell that is silver plated. I had no time to do anything else. The gold around the edge is actually gilding. So it's very, very, very thin gold around there. This is gold at the join there and gold at the mouthpiece. The other instrument, this is what the military instrument. And this is basically copper or bronze, we don't know which. I made it in copper. And the center section I made, the black section, you can see, I made and patinated black, and that looks exactly like what was found. What we never know is whether that was black when it was buried, or whether being buried for 3,500 years, it went black. We just don't know. What is interesting about these instruments is that when you blow them, and all the literature tells you, they can play 2 or 3 notes. They don't have a conventional mouthpiece. They have a very open mouthpiece. And I have a friend in Germany who is a little bit more than a good trumpet player, is among the best dozen in the world. And he can get about 11 notes out of this thing. Now, the question is, what did they do in the ancient times? Were the trumpet players very good in ancient times? Did they practice in ancient times? And much of music archaeology is written by modern people who are archaeologists or musicologists, not people who play. And I feel that I come from a tradition of playing, and I find it very hard to believe that the people who would use these instruments would not have practiced and would not have been very good at playing. I don't say they're as good as Marco, who can play fantastically on this thing, but I do say they're much better than most people give them credit for. And when you work on ancient things, you start and build up a tremendous respect, both for the people who use things, but particularly for the people who made things. There are just some things you look at in a museum and you think, that can't be true. They're just so good. The interesting thing about these things is, if you look at the wooden, that both instruments had a wooden insert which fitted the instrument exactly, and one of them had warped as the instrument itself had warped. And they're decorated with the lotus leaf. And of course, the lotus leaf is a symbol of resurrection. And the instrument, the silver instrument, was decorated with a lotus leaf. And the silver was the color of the temple. So that was clearly, to my mind, a temple instrument. But when Tutankhamun died, he wasn't supposed to die. He was only 19. And they now think he fell off his chariot and got run over, which I suppose wasn't a good idea. And suddenly they needed instruments for his burial. And the lotus leaf pattern is rubbed off on the bell of the silver instrument. Now you can do that because the instrument is so thin. It's like paper, the silver. And then the king's cartouche, the king's sort of signature, is painted upon, is engraved upon that instrument. So this instrument tells you an awful lot about the history, what was going on at that time of the thing. Now the phone is going, just to show you the problems of Zoom. Within EMAP, my thing I wanted to do within EMAP was to get the people involved in EMAP to look at the scope of brass. And when I'm doing anything like this, I always do these things, whatever you call them, mind maps or bubble diagrams or whatever you like to call them. I find these tremendously helpful. I find them, they take a lot of doing, but the doing of them itself is something useful, because it gets you to really think about what the connections between things are. Now, in doing this and presenting it to EMAP, I failed because I couldn't get enough interest in it. But to me, this is the only way, when you've got something as complex as these instruments and the meaning of these instruments, this is the only way you can really get to grips with it and start to try and understand them. And I just use the term their meaning. I've been working on music archaeology since the 60s, but when I started working on it, everybody was busy saying this instrument is so long and it's this thing and it plays in F, or it does this, or it does whatever. There was very little about the meaning of these instruments. And we are now starting to to see and to understand what the meaning of these instruments. We have to break ourselves away from seeing these as musical instruments, because the term musical is really so dangerous. If we say this is a trumpet, then what comes to my mind in a trumpet is Louis Armstrong. And if you've got Louis Armstrong in your head, then I'm afraid if you're trying to look at Bronze or Iron Age music or sound, then you're giving yourself a problem. So the game has very much changed since the 60s. And it's gone into a period where we're trying to look at the meaning of these instruments and what they meant for their societies. Many of these instruments had tremendous meaning in their societies. And we see that through all sorts of different religious ideas. Brass instruments are there in all sorts of different religious groupings. This is a good example, one of the instruments, the carnix. This is from a cauldron, Gunderstrup in Denmark. And these instruments are played vertically and they've got animal heads on them. So this is an example of animization. This is an example of instruments being given life. They were not just musical or sound tools. I prefer to call them sound tools because it's less pejorative. It's less definitive in telling you what we think they were there for. And the animal heads these are clearly animistic things. Here you see a frond going across there, and to me this is and there's only me believes this, I think, but I believe this is the lotus leaf, and this is the imagery showing the difference between the human sphere and the celestial sphere. And here above it, you see the serpent, and the serpent is everywhere. It's there in all sorts of religions, there as symbol of all sorts of different things. In many religions, symbol of resurrection. So this is an example of trying to understand the things. We didn't have many cornices until 2004 when 7 were found at once. So we now have a wonderful story on the cornices. I don't want to go through this. This is my own personal cornix I made. I didn't make, this is the one thing I've made just because I wanted to. Most things I make because somebody asked me to, or there's a museum wants something, or an exhibition. I made Albert Henry just because I wanted to make it. And if you wander through the water jet cutter in the Grove, you'll see various things of this crest on there. It was made on the water jet cutter, and you'll see various bits of it around. But this is a typical example of a cornix. And again, I did the same thing from the cornix to try and get myself to understand what the various bits of the cornix, what the meaning of them was, and just how we could fit them all together. The cornix, there is no question about symbolism in the cornix. It's got an animal head on there. The animal heads are very different on all the different pictures of it we see, all the different iconography. And this is where one of the problems comes in. The iconography of the cornix comes from the Romans, principally from their coins. And there are just hundreds of Roman coins which depict the cornix. And they are using that to symbolize the people they have conquered. So the pictures we've got of the cornix are not from native Iron Age people in general. They're from the Romans. And we have to ask the questions of really about how much can we believe those? Can we really believe that the Romans were copying these exactly? We do have some. The principal coins that are native European coins, pre-Roman, are from France and a few from Britain. France, there's a lot from France. So they give us some sorts of ideas. If we look at these instruments in general, these are Etruscans. These are the people who inhabited northern Italy before the Romans took them over about 120 BCE. One of the things on the iconography here is that you see some have black faces, some have white faces. All the males were always drawn with black faces. All the females always drawn with white faces. I don't know about this because this is a very degraded sort of piece of painting. These are wall paintings that lined the Etruscan tombs. The Etruscans were very much into tombs and very much into, they actually in some places took out the bones of the dead people and laid them out outside the tombs, and they had very strange rituals. But we have two instruments here, the curved thing, which is the cornu, which the Romans took over, and the second one, this J-shaped instrument, the lituus. And this is where we get some of the evidence from. This is in a tomb from Tomba dei Rilievi. This tomb was carved out of the solid rock. So somebody went down, carved their way down there, carved this space out, and carved the whole tomb out of solid. It's tufa, a volcanic rock. It's a volcanic area, and it's not a hard rock, but they carved this out, and they carved these instruments out in relief. They are just amazing sorts of tombs. When it came to making for EMAP, I decided that this was, because there was a cornu and a lituus together, I decided this was the instrument I was going to use. And this is the picture on the wall. This is the sort of evidence you have to go from. It's absolutely beautiful. It's the whole instrument there. And you can do this drawing. I did this drawing on a freezing cold January morning. I never believed Italy got so cold. And it gave us all the information we needed for making this cornu. Making it was another question, because I was working with an institution, and I don't get on that well with institutions, I've decided. The money had been paid by the European Union to the people running the thing in Italy, but by God, it was hard to get the money out of them. And I could not get the money out of them to pay for this intro. I didn't have time to make this myself, and it was a very elaborate thing. So my colleague, Martin Sims, he made this instrument. And I'm afraid that was the only instrument we had over much of the exhibition. It was made in fiberglass, beautiful piece of work. It worked perfectly well, and it was played. Whatever. This was made by Jean Boiserie in France, an atelier in France, a brilliant craftsman. The key thing about this was that had I made this exactly like the iconography, which is what it looks like on this picture on the right, you can't play it because you can't get your head in. Your head is stuffed between the bell and the mouthpiece. So I had to put another piece in here where you see this little lump sticking in there where you can bend the tube out so that you can play it. So we can look at the archaeology, we can look at the iconography. The iconography looks fantastic. We can make something exactly the same, and then we find it can't be played. So this experimental archaeology has its value in enabling us to understand and interpret the material. Now, another problem came with the lituus. This is the lituus in the same tomb. And the lituus is on the very left here, this long, great J-shaped thing. The litui had long mouthpieces, same as the tuba. The Roman tuba had very long mouthpieces. So we did not know how long this instrument should be. This is a cylindrical instrument. The tuba is a conical instrument. They both have different organological characteristics. So we had a great problem trying to match. I wanted the two instruments to play together. So it took a lot of work to get some help from a professor of acoustics at Edinburgh University. And we produced this sort of thing. This was the theoretical view of the harmonics. So in theory, if all the harmonics were in tune, in line with the harmonic series, all these lines would be on the same, they would be on the same vertical line. So you can see they are really pretty close and whatever. So we used that method to try and work out exactly how to make this instrument so that the two instruments would play together. The guy then used this drawing in a book without referencing me, but that's another matter. Trying to understand these things and trying to do something is really very difficult, because the more you know about brass instruments in a modern sense, the less useful you are in trying to understand them in the ancient world, because you know exactly how brass instruments work. You know everything about them. You understand them totally. And that's really not what you want. What you need is a jack of all trades who knows nothing about everything. And it's only by, when you come to approach this ancient world, you have got to so much forget what you know about the modern world. And it makes it a very difficult sort of exercise. Just one little brief thing is here, that when we get a bit of tube today, we buy a bit of tube. We buy it. It's been drawn, seamless. You couldn't do that in the ancient world. In the ancient world, you had to get a piece of sheet, wrap it over, and then seal it. And sealing it was the big problem. If there's any leakage at all, the thing does not work. And this is where I found this sort of exercise very useful. We have here the word carnix, which is native European. We have here lituus, which was Etruscan. We have this enormous similarity in the techniques. And when you start and follow this through, this tells you an awful lot about the interrelationships between the Etruscans and the native Europeans. Technology travels. And technology travels far better than other cultural aspects. And people ignore the culture of the technologist. I have to watch the time. I worked on the Rudevelt. I worked on the luas. The luas are instruments from between 1500 BCE and 500. And they were made in Scandinavia. They were made in, well, that's wrong. They were made in northern Germany and Scandinavia. And the key thing about them is this is the Rudevelt luas. I did a lot of work on these things. I spent weeks and weeks and weeks measuring them. And they're made in pairs. So you've got a right pair and a left pair. They are within a millimeter. They're 2.5 millimeters long, but they're within a millimeter or so of the same diameter at any point on these. And they are cast, and they're cast 1 millimeter thick. They are the most phenomenal piece of technology from the ancient world. I've published this several times. It has never, ever been cited by anybody anywhere. I did a talk at the Institute of Physics. I presented this at the Institute of Physics. I did 17 broadcasts on radio and television from that talk on the Institute of Physics. They appreciated it. Archaeologists, they say, boring. Yeah. This is the problem. This is the problem technologists have. Technologists are the key to all these things, but they don't feature. And they are poo-pooed, and they are just makers. They are just metal bashers. But these things developed because of this inordinate skill of these people to cast things 3,500 years ago, 2.5 meters long, with phenomenal accuracy. And we don't know how they did it, but they did. Another instrument quickly we worked on was this Poetovio tibia. This was on EMAP. This was the instrument in the making. This is the only totally brass instrument from the musical instrument from the Roman world. Brass in the ancient world was a precious material because they didn't have zinc. So they couldn't make the copper zinc alloy brass. They had to make the alloy by smelting zinc ore along with the copper. This is the own, so this was clearly a very, very special instrument. Just another thing of when we were making it. I was criticised for spending a lot of time making, and I did spend a lot of time making this. Nobody paid me for it, so I don't know why they could criticise me. But it was going to Slovenia. This is one of the crown jewels in Slovenia. This is what it looks like, the original. The exhibition was going to Slovenia. To them, it was everything. And what you're doing in music archaeology, okay, you're trying to understand the technology, trying to understand the music, but you're also trying to engage people. And this was the way to engage the people in Portovio. And this was one of the nicest instruments I think I've ever made. It was absolutely beautiful. It has a mechanism here. It has 3 layers of rotating sleeves, and it has a mechanism so that you twist the inner rotating and it adjusts 4 holes automatically. It was the most unbelievable. Everybody tells me nobody appreciates this mechanism. I do, because it took me ages to make. Everybody says, oh, they like these bits. Those bits didn't exist. I did them at the last minute just to get the length right. This is the problem with music archaeology. But it did the job. It raised interest, and that was the aim of it. I worked also in Boston on these instruments, where 400 bits of instrument were found. Somebody then organized them by color. Somebody then reorganized them by length. Somebody organized them by God knows what. So they were in a mess. And so we had to start and work out how to make them. I don't want to talk about this. One of the key things on mouthpiece, and I'll talk about mouthpieces in a minute, was they're very important to brass instruments. You change the mouthpiece, you change the instrument. In the question of the Lewis developed a mouthpiece from scratch to become what would a modern trombonist would look at today and say, that's a modern trombone mouthpiece. Then at the end of the Bronze Age, they stopped, they disappeared. Then the Etruscans started again to develop the mouthpiece. So there is no continuity in many of these things, and we have to be careful. People say to you all the time, oh, did this come from this? Did this come from that? People are inventing things all the time, and we can't always assume that there is any continuous line of development. We have to be very careful. Just the book. Of course, this is the book. Yes, this is the book. Just to show that I can master electronic things and physical things together, I produced this book. It's book 1, and I produced it as a print on demand. So this book doesn't exist until you order it. And if anybody does have an idea they want to put forward and sell, I can thoroughly recommend this. Unfortunately, it's done by Amazon. That's a shame, but you can buy this book, and as I say, it is printed on demand. And the books actually look very nice, the finished books. They look like a book, they feel like a book, they open like a book. So this is, in a sense, the bringing together of the digital and the physical world. If I need to get out here now and to go to try and find, I've stopped screen sharing. I'm just going to try and find something. Where is it? This is where everything goes wrong. So just talk among yourselves. Right. I'm going to now share my screen again. And isn't science wonderful? I have been, when I left Middlesex University, the engineering I'd done and the engineering I'd been involved in was very much physical manufacture of things. The digital world hadn't happened then. But coming back, I found the digital world. And one of the problems with brass instruments is this question of mouthpieces. And if you look at, there's a story of the first trumpet at the English National Opera. He'd go in every night, he'd open a cupboard and there'd be 50 different mouthpieces and he'd choose which one he was going to play on tonight. And I'm not quite that bad, but I do have boxes of the damn things. So I decided that what you should be able to do is you should be able to, and I did this with my son, you should be able to make a site where somebody can design their own mouthpiece. And that's what we set out to do. And this is the result of it. It was successful to an extent. The reason it wasn't successful was because, well, let me show you how it works, that's all. You can go either to a full picture of something, a half picture of something, or you can rotate it and do all sorts of different things with it. But from the point of view of a player, you can have all sorts of different sizes of mouthpiece. Let's go to a half mouthpiece and let's just go to the cup. So here we see the cup. The big parameters that a player uses are things like the depth of the cup. So if you watch the picture in the middle, as I change the depth of the cup, it's changing the depth of the cup. Yeah. As I change, oh, sorry, the diameter, that was the diameter. Sorry, that's the diameter of the cup. As I change the depth of the cup, it changes the depth of the rim rise, which is the rim at the top, or I can change the rim back again. I can change the rim width. Just as an example of the rim width, if you have a very wide rim like that, it makes it very difficult to change notes quickly, but that might be what some players want. If you have a very narrow rim like this, it makes it very easy to change notes quickly, but then it tires your lip more. Now, the aim of this site was, having made it, having designed what they wanted, the user could then just click, and we would send this to an agency and they would print the mouthpiece. And we got it all working for different mouthpieces. And the problem then came that the quality of the 3D printing was just not sufficient. So that's where the project fell to pieces. At the moment, the plan is that we will make this open for anybody, and we will allow them to export an STL and do what they like with it. We cannot set the system up so that somebody would be able to do it. But I do have Roman mouthpieces in this, so this should enable people to look at different Roman mouthpieces, to experiment with different mouthpieces on different instruments and to play around with them. So this is if we look at the full instrument, look at all the instrument, then we can have all these different kinds of instruments that people like. A lot of people like this thing. I don't know, I don't understand why, but people do. So this was an experiment that we did. It can be printed in lots of different plastics. It can be printed in metal, but none of them were good enough quality for us to be able to just ship straight to a user. And that's where the project fell. So we've changed the project. So that is pretty well it. I have a slide which says thank you for listening, but I'm not sure if I could get back there again. So I would be happy to answer any questions which might have arisen.
Amazing, Dr. Peter. A fascinating, fantastic talk touching on your journey, and also a journey across instruments from the ancient world, obviously with the most recent example being the mouthpiece.store, also touching on the digital age as well, alongside all those fascinating reconstruction pieces that you've used, like 3D printing to kind of reconstruct those particular ancient instruments. So thank you for that talk. As usual, guys, feel free to gather your thoughts, your questions, your comments in the chat. We're going to have Q&A now as well. So there's obviously an option to go live and interact with Dr. Peter as well after just put a little request in the chat there as well. First question, Dr. Peter, what was your experience like in terms of the finding of these pieces, these different ancient instruments, and then trying to reconstruct them? Like, what's the process that you undertake?
Well, there's various processes. It depends whether that you're making something from an object, a physical object, or from a piece of iconography. The vast majority of, altogether, there are around 400 pieces of physical instruments. The majority of those are late Bronze Age. When we come to for instance, the Roman world, there is one instrument from the Roman, and if we think of the tens of thousands that were around. So at the time, we have just one left. So that is the problem. If you're making something from an original physical thing, it is probably much more straightforward. But then there are questions to be asked. One of the questions to be asked is, how important is the material? Very often we don't know what the material is. We usually say it's bronze. It's an alloy of tin and copper, and we make it out of a modern bronze. When I made the Tutankhamun things, I decided I would make it about the original materials. So there are lots of questions about what you are trying to do and why. When we are looking at, we're working at the moment on Greco-Roman instruments which have mechanisms on them which are fascinating. We are 3D printing them because I don't care what they're made of. We're looking at the mechanisms. We're trying to understand the mechanisms and what these mechanisms would do for people. So it depends very much on what you're doing it for. For instance, we're making these Greco-Roman things, hopefully for a concert in September. And so I'm quite happy to have them made as 3D printed and not necessarily as metal things.
Amazing. A question coming through from Shimon Fiddler. You said when you started at Rolls-Royce that they had no digital computers. So Shimon's asking, does this mean that they were using analog computers at the time?
They did use analog computers, yes. So they'd use an analog computer that, one computer that modeled a compressor, one that modeled the flame cans, one that modeled the turbine. So they would use different analog computers and plug them all together to try and analyze the whole thing. I mean, the chips weren't there for digital. So yes, they did use analog.
Amazing. Amazing. Another question: what's your most favorite piece that you've worked on so far?
In terms of instruments.
Instruments, exactly.
I like Albert Henry. I like the Carnix. He looks nice. He's got a nice. Albert Henry was my granddad, and I like him. But on the other hand, the Poetovio, the one you saw, the tibia that was very, very highly decorated, I spent hundreds of hours decorating that. And that was immensely satisfying. At the same time, the Tutankhamun, particularly the silver instrument, was, I don't know, it's the last one I made. My favorite one is the last one I made. Amazing.
Is that always the case, the last one, and then you kind of enjoy the next process?
Well, yes, because you put yourself into it. It's not the sort of job you do just for, I've never made instruments for money, and I'm not interested in making instruments for money. I make them because I want to understand them, or I want them to be part of an exhibition and to help people to understand how these instruments work. I think it's important for people to physically see them. If you look at the Poetovio instruments in the museum, you've got a box full of green things. If you see the actual instrument, it's an instrument, and it really changes the view of people when they look at these things.
Amazing. Another question, in a similar way, what's been the most challenging or difficult in terms of research and reconstruction so far?
I think one of the most difficult ones was I undertook in the 1980s to make a lure, a pair of lures. And I got I'd had a PhD student who got his PhD working on shakudo and shibuchi, Japanese alloys for sword guards. He was a silversmith. And I said to Nick, oh, do you want to do this? There's £18,000. It sounded an awful lot of money. £18,000 for doing it. And he said, oh, I'll do it. And we worked together on it, although he did it mainly. And it took 5 years to do. And we did manage to make the first pair of lures that would have been made in the same way as in the ancient world. But it was excruciatingly challenging. And that taught me that I had done a lot of casting. When I was at Trent Park, I had a foundry, a little foundry that was outside a proper Bronze Age foundry. And we did a lot of work on trying to make things by the original methods. And I decided at that time that that was okay as an exercise to try and understand the technology. But what I was interested in was to understand the musical aspects or the sound aspects of these things. I was less interested in totally reproducing the technology, because at the end of the day, when you think you've reproduced the technology, you can't be sure that you have.
Mm-hmm. Definitely. And I guess, obviously, considering your very long and distinguished career, how would you kind of characterize the changes and developments, from your time following your apprenticeship and joining Rolls-Royce until today? Like, what's been the key milestones in terms of the design and engineering sector?
Well, I think the key thing has to be digital. It has, even if you're physically making things, digital has changed that. And I think the whole aspect of modeling these things has changed everything. When I started my apprenticeship, you had a 2D piece of paper, 2 dimensions, flat sheet of paper, and everything was in 2 dimensions. I was working on gearboxes, which are complex 3-dimensional things with holes drilled through. And I worked with a guy, and I can remember his name, Joe Land, and he'd look at me and he'd say, look, this hole here, and it was a hole going through at an angle with another hole going through it. He said, I think that wall thickness is too thin. And that was the difference. It was having to understand 3 dimensions from 2-dimensional drawings. That has changed, and that changed everything enormously. The other thing, of course, that changed was the ability to simulate. We had no abilities to simulate anything. If we wanted to test if something was working, we made it. We made it and broke it. And we spent a lot of time breaking things just to try and understand. And that was the problem. An example of the Rolls-Royce had an engine called the Tyne. It was a beautiful engine. It was very unsuccessful. It went into service and it was crashing. It was the turbine was blowing up. We had it on. I worked on test beds at the time. We were doing flights from Heathrow to New York, and we got faster and faster on this engine. We couldn't break it. We couldn't break the engine at all. They tried everything to break the engine, and it killed the engine. It was the 44. It was a turboprop engine, and the project failed for that reason. And what had happened in the end, all the engines we had were made in Derby. The engines that were failing, nobody picked this up, were being made in Kilmarnock. And the difference was, in Derby, the discs were heat treated and were dropped into a vat of oil to temper them. In Kilmarnock, they were put into a tray like that, and a number were dropped into a vat. And so the bottom half of them was tempered quicker than the top half. And that was causing stresses and that was causing failures. And there was no way of simulating things. And it was very difficult in those days to think of all the stages in manufacturing and what those stages could be. Just one very quick example, when Rolls-Royce engines started going to service, they had stainless steel oil tubes. Pratt & Whitney had stainless steel oil tubes, and the oil tubes were failing at Pratt & Whitney. And nobody understood why until somebody realized that everything at Rolls-Royce in Derby was made by men who had previously been making Rolls-Royce cars. All the oil pipes were polished. Everything on those engines was polished. And of course, stress raisers caused metal fatigue, and the pipes on the Pratt & Whitney engines were not polished. And just small things like that. And that happened with compressor blades, that all the compressor blades looked fantastic because these guys had been polishing flying ladies off the front of Rolls Royces, and they kept doing it. And it's this culture within organizations that is buried deep inside organizations that once you destroy an organization, you destroy that culture. And it will take generations to build it up again. But I'm on a hobby horse here, so I'll shut up.
No, that's fascinating. And in terms of the kind of archaeology of ancient instruments, what's the latest and what's next?
Well, what is happening now is that archaeology is getting much more precise. So we are getting remains found that would have been not seen in the past. So we are getting things recovered that enable us to find much more. A big example of this is in the Iron Age. A lot of the organic material that would have been thrown away in the past is now being preserved, and we are understanding there was much greater use of psychotropic substances in the Iron Age because they're surviving and they're able to look at them. Fragments of material that would have been thrown away and discarded in the past. I mean, archaeologists in Egypt used to keep warm by burning papyrus because nobody could read it, so they burnt it. And it's all gone. And what's happening now is much more is being recovered, and people are adopting a much more scientific approach to the whole business of things. But not everything is coming from digs. What is happening is that that museums are vast storages of things, vast warehouses of things. Something like 10% of a museum's objects are on show. And with better education, with more publications, the internet particularly has changed all this. I can find articles now that I would have had to go down to the British Library to find. So the whole research has been speeded up by the internet. And this means that things that are in museums are being recognized by people in museums, and the whole internet and information age has speeded up understanding enormously and has made the most enormous difference to things. When I worked at the British Library, when it was at the British Museum, if you wanted to find something, you went and looked at a book that was this big, and you looked down for something, and then you filled a form in, and like nowadays, before I go to the British Library, I order everything online. So I get at the British Library and it's there ready. Many of the papers I don't go to the British Library for because I get them online. And this information is speeding up understanding, not just in archaeology, but it's doing that in everything.
Amazing. And that leads us on to then the last question. So in relation to AI and artificial intelligence, how do you think that could benefit the kind of archaeology realm and domain?
I think it could benefit. The problem with AI is it's at a dangerous stage at the moment. And the question with AI is AI going to produce something that's totally factual? is it going to produce something that's suppositional based upon a set of facts? I think both are useful, because if it produces something that's based on some supposition, it can point you in directions which will help you to investigate that. And part of the business of archaeology is having the right sort of eyes. I walk in anywhere and I see trumpets everywhere, even where they aren't. But my rule is that somebody's got to prove to me that that's not a trumpet. Yeah, if I say it's a trumpet, their job is to prove it's not. And this is what AI can do. It can give you those eyes that help you to start and see and to start and look for things in a different way. Your eyes become accustomed. I started working on the agonistic, the Greco-Roman stuff, on these instruments with mechanisms. I found one, and then I saw another, and then another, and then another, and then another. There were pictures I'd had for years, for decades, but I didn't see them because my eyes weren't ready for them. And if AI can do this for us, not necessarily tell us the answers, but point us in a direction which helps us to look in a different direction, then AI has got a very useful future, I think.
Amazing. And just to finish off, Dr. Peter, with your experience, your expertise, what would be your final advices or takeaways for these students across design and engineering?
I think the main thing is, I said at one stage that this thing, people who know everything about nothing and people who know nothing about everything. And I still believe this is really important. If you are working on something, you've got to be able to use the expertise of other people in a sensible way. And I think the main thing you should take away from anything like this is that to understand how to use the advice and the understanding and the expertise of other people, because you don't know everything, you can't know everything, and other people bring all sorts of expertises to play. And particularly in this world where the world is becoming a very complex place, and it's knowing when you can trust other people's, the information for other people. And I think the thing you've got to learn to do is how to establish whether you can believe somebody or not, or how to test out for yourself that how good that person's understanding is. And I think that's my main thing, is to be careful about specialization, because the big changes come on the edge of specialization. Specialization is people like CERN and people like that with shed loads of money. Yeah, and I think that for small innovators, it's around the edge of society, and it's a question of knowing how to use the expertise of other people.
Amazing. Amazing. Dr. Peter, thanks for taking out your time and joining us tonight. It's a brilliant talk and a great Q&A session as well. So from all of us at Middlesex University Product Design and Design Engineering, we thank you for your time and for the talk as well.
Yep, thank you.
Amazing. For all students and participants, you'll often see Peter in the workshop with Spike as well. They're making, they're refining, and they're doing lots of blowing. So if you see Peter with Spike, obviously definitely feel free to connect and talk anything related to instruments and ancient archaeology, and Peter's your man. And to conclude, guys, keep an eye out on your emails for the details of the speaker and links to the talk next week. And until then, stay well, stay safe, and thank you, guys.
Thank you. Bye.